All right, so here we are for our variables on both sides, day 1 notes. Okay, so learning target. Today you will be able to solve equations with variables on both sides. The key idea and the main idea for solving equations with variables on both sides is to add or subtract, whichever one you need, variable terms to move the variables to the same side of the equation. So basically that's saying use inverse operations. Okay, so if you notice, we have 2 examples down here, and these are not focused on solving, but these are on understanding about movement. Now, when you have equations with variables on both sides, the only way for you to be able to ultimately solve that for the value of that variable is by getting all of your variables onto one side of the equation. You cannot solve when you have variables on both sides. So you're going to have to move them just how we move everything else by doing the inverse operation. So in this case, we have 3x on the left and negative 8x on the right. The good thing about doing these, moving these over, it doesn't matter which one you move over. It doesn't matter which one you pick. You can move everything to the left, which is my preference. You can move everything to the right. Or you can some people just look and say, well, which one is the smallest number? That's the one I'm going to move. Okay, but it doesn't matter. So we're going to practice this first one, and we're going to move the 3x over. And it's a positive 3x, so I'm going to do the opposite operation, and I'm going to subtract 3x on both sides of the equal sign. That cancels out to 0. I bring down this 5. Negative 8x minus 3x is negative 11x. And then I just bring down that plus 11. Okay, remember, this part is not focused on solving. Now I have a 2-step equation. I already know how to do that, and so I just go and solve it as regular. So our new skill is first moving the variables all over to one side. So we'll try it again with this one, and this time I will do the opposite. So I'm going to move the 8 over by doing the opposite operation and adding 8x. That gives me a positive 11x plus 5 equals, these canceled out, and then bring down that plus 11. Or you can just put, I don't know why I did that. We can just say positive 11. There we go. Now, if you notice, the equations are not exactly alike, okay? So this equation over here is not quite the same as this one over here. There's a small difference. That's negative 11x, and this is positive 11x. However, that does not matter. It doesn't matter because as long as all of your computation is done correctly, the rest of the way solving the problem, you will get the right answer no matter which way you moved it. And I'll show that on one of these other examples below. So we'll get to this one. We have 5x plus 2 equals 2x plus 14. Which one do I want to move? It doesn't matter. I personally, my preference is to go and move everything to the left-hand side. It's just how I like to go and look at it. So I'm going to subtract 2x on both sides. I get the 3x, bring down the plus 2, equals a positive 14 because these canceled out. Now I have a regular 2-step equation, and I'm just going to solve as usual. As those canceled out. So I'm going really fast on the solving because we've been doing two-step equations for a couple of weeks now, so that's not our focus. You guys have a good hang of that. And so over here, I'm going to, let me use the green. I'm going to go and show you what if I move the 5x over? So using that same equation, I'm going to do 5x plus 2 equals 2x plus 14. Okay? So I'm going to move the 5x this time. It's a positive 5, so I'm going to subtract. Okay? These cancel out to 0. I bring down the 2. 2x minus 5x is going to be negative 3x. And I have plus 14. I still have a two-step equation now, but I have to move that constant by subtracting 14. I get negative 12 equals negative 3x. Divide by 3, negative 3. Divide by negative 3, x equals positive 4. So if you notice, that's positive 4, this is positive 4. So that should show you it doesn't matter which side you go and move it to. As long as all of your steps are mathematically sound and mathematically correct, you're going to get the same answer no matter which way you move it to. That's why I really like working with these, because either way you're going to get the correct answer. So with this one, I'm going to show you, I'm going to move the 6x this time. And once your mind kind of gets understanding the process, you can kind of start seeing things ahead of time and why it makes sense to go and move this 6x. Those cancel out. I have negative 7 over here. Negative 4x plus 6x gives me a positive 2x. So you see that made my variable positive. So in that case, moving the 6x, made sense. But either way, it doesn't matter. So I got plus 3. Now I have a two-step equation, and I'm just going to solve it as usual. And we got negative 5 is equal to x. So once again, kind of that same skill set. So we'll go down to the bottom. And we'll move 7x plus 2x equals 4x minus 10. I'm going to subtract 4x on both sides. I get 3x plus 2 equals negative 10 because those canceled out. And I have a regular two-step. And I'm going to go and just solve as I know how to do. And bring down the 15. So I moved the 2x over. It was just easier. It's just easier. Add 10 on both sides. Bring down the 5x. Those canceled out. 15 plus 10 is 25. 5 times blank equals 25. This should be an easy one. X is equal to 5. So as you can see, we only added one new little layer. There was only one layer, and that is moving the variable over before we get to solving. All right, so on this next example, these are with word problems, and I'm showing you this just so you can kind of get an understanding of how they would ask this in a word problem format. So if you have an equations with variables on both sides, that means you're going to have two equations written into one problem. So we look at this problem. It takes a graphic designer 1.5 hours to make one page of a website. Using new software, the designer could complete each page in 1.25 hours. But it takes 8 hours to learn the software. How many web pages would the designer have to make in order to save time using the new software? Okay, so first we're going to go and define what our variable is. Our variable is x, and x is going to represent hours. And so I always like to go and identify what are my two equations. And so in this case, I'm going to use, this is going to be my old information. So that's like the old software or just him doing it. And this is going to be my new software. Okay. So with the old software, it takes him an hour and a half to make one page of a website. So I can say that is represented by 1.5x. Okay, so 1.5 hours, and the x for your pages. Actually, I defined that wrong. That's your number of pages. My bad. Okay, is equal to, then it says each page, so 1.25 hours for your pages, but it takes 8 hours to learn the new software. So we have to take that plus 8 into consideration. Now, we have an equation. We have variables on both sides. We can solve this, but we have to decide what we have to move. When you have an equation that is set up like this, where you have, like under the old side, there's no constant that you're adding or subtracting. You only have 1.5x. So that means that if I were to move the 1.5x to the right side of the equal sign, 0 would be left on the left. That's the only thing that would be there, and I would ultimately have to move something over. So when you get these type of setups, you know that that your variable has to be moved to the right because it's the only thing that makes sense. So I'm going to move this over. This comes to 0.25x. That's 8. And I divide by 0.25. And x equals 32 when I do that. Now think about this. This means in the real world relation of the problem, the designer would need to make more than 32 pages. So after he makes 32 pages, it makes sense. He's going to save time by having learned how to use the software. Okay. All right. And so then we have our next one where, let me get these little markings off. Okay. An office manager spent $650 on a new energy-saving copier that will reduce the monthly electric bill for the office from $112 to $88. In how many months will the copier pay for itself? So X is going to be equal to months. And then we can still use not the new on this side, the old versus the new setup. So how much are you paying per month? What are you just normally paying? All right, $112. So 112x. So $112 per month. But your new bill will be $88 per month, which is X. But you had to factor in that you spent $650 on a copier. Okay? So now we have to go and solve to see when will it be cost effective. Okay, so when will you have paid off the copier price and you're saving money with your bill. Okay, so once again, this setup has it where it only makes sense to go and move the 88, because if I move the 112x, there wouldn't be anything on the left, and then it would cause me to do double work, and I have to move something else over. So that gives me 24x equals, bring down the 650, divide by 24, and then x equals 27.08. All right, In real world, we do not measure months like that. You have a full month or that's it. So after how many months will the copier pay for itself? So we need to make that 27.08 in order to answer the problem realistic in the real world. You don't have a decimal of a month, so we have to factor in, you can't have a part of it. So after 28 months, okay, that's when the copier will pay for itself with the amount of savings you're doing. All right, and finally, I want to go over combining like terms versus your variables on both sides. So sometimes people get this confused, and they're like, well, what's the difference between combining like terms with the variables on, the same side versus variables on both sides of the equation? Well, we're going to look. So if I have 3x here and 2x here, they are on the same side of the equation. I can just combine them straight across. 3x plus 2x is 5x. Bring down that minus 7 equals 10. And I can go and solve this all the way. I'm going to solve this through. All right, we got x equals 3.4. Now, here's the difference. When you have the variables on two sides of the equal sign. So we have 3x over here, and then we have 2x over here. I have to move them. I can't just combine them. So I can't just go and say, hey, I'm going to add them together and see how many I have in total. I have to do the opposite operation because they are on opposite sides of the equal sign. So I'm going to move the 2x over because it's easier for me. That gives me 1x minus 7 equals 10. Add 7, x equals 17. So we could say that, so if it's the same side, you do the same operation. And we can say if it is the opposite side, so if your variables are on the opposite side, we use the opposite operation, which we also know as inverse. But I would say opposite operation. All right, and so those are your notes. So the only thing that was new was that you now need to move all your variables to one side of the equation, one side of the equal sign, okay? Move them all over by doing the inverse operation. And that's it. And the thing is, it doesn't matter which one you move, as long as you're solving your equation correctly, mathematically, all your computation is right, you will get the same answer no matter which direction you move.